All sciences, including the social sciences, employ variations of what's called the scientific method, a systematic approach to research. For example, a psychologist who wants to know how noise affects people's ability to learn chemistry, and a chemist interested in measuring the heat given off when hydrogen gas burns in air would follow roughly the same procedure in carrying out their investigations. The first step is to carefully define the problem. The next step includes performing experiments, making careful observations, and recording information or data about the system, the part of the universe that is under investigation. In the examples just discussed, the systems are the group of people the psychologist will study and a mixture of hydrogen and air. The data obtained in a research study may be both qualitative, consisting of general observations about the system, and quantitative, comprising numbers obtained by various measurements of the system. Chemists generally use standardized symbols and equations in recording their measurements and observations. This form of representation not only simplifies the process of keeping records, but also provides a common basis for communication with other chemists around the world. When the experiments have been completed and the data have been recorded, the next step in the scientific method is interpretation, meaning that the scientist attempts to explain the observed phenomenon. Based on the data gathered, the researcher formulates a hypothesis, a tentative explanation for a set of observations. Further experiments are devised to test the validity of the hypothesis in as many ways as possible, and the process begins anew. This figure summarizes the main steps of the research process, the three levels of studying chemistry and their relationships. Observation deals with events in the macroscopic world. Atoms and molecules constitute the microscopic world. Representation is a scientific shorthand for describing an experiment in symbols and chemical equations. Chemists use their knowledge of atoms and molecules to explain an observed phenomenon. After a large amount of data has been collected, it's often desirable to summarize the information in a concise way as a law. In science, a law is a concise verbal or mathematical statement of a relationship between phenomena that is always the same under the same conditions. For example, Sir Isaac Newton's second law of motion, which you may remember from high school science, says that force equals mass times acceleration, or F is equal to m times a. What this law means is that the increase in the mass or in the acceleration of an object will always increase its force proportionally, and a decrease in mass or acceleration will always decrease the force. Hypotheses that survive many experimental tests of their validity may evolve into theories. A theory is a unifying principle that explains a body of facts and/or those laws that are based on them. Theories, too, are constantly being tested. If a theory is disproved by an experiment, then it must be discarded or modified so that it becomes consistent with experimental observations. Proving or disproving a theory can take years, even centuries, in part because the necessary technology may not be available. Atomic theory, which we will look at in Chapter 2, is a case in point. It took more than 2,000 years to work out this fundamental principle of chemistry proposed by Democritus, an ancient Greek philosopher. Scientific progress is seldom, if ever, made in a rigid step-by-step fashion. Sometimes a law precedes a theory. Sometimes it's the other way around. Two scientists may start working on a project with exactly the same objective, but will end up taking drastically different approaches. Scientists are, after all, human beings, and their modes of thinking and working are very much influenced by their background, training, and even their personalities. The development of science has been irregular and sometimes even illogical. Great discoveries are usually the result of the cumulative contributions and experience of many workers, even though the credit for formulating a theory or a law is usually given to one individual. There is, of course, an element of luck involved in scientific discoveries, but it has been said that chance favors the prepared mind. It takes an alert and well-trained person to recognize the significance of an accidental discovery and to take full advantage of it. More often than not, the public learns only of a spectacular scientific breakthrough. For every success story, however, there are hundreds of cases in which scientists have spent years working on projects that ultimately led to a dead end, and in which positive achievements came only after many wrong turns and at such a slow pace that they went unheralded. Yet even the dead ends contribute something to the continually growing body of knowledge about the physical universe. It is the love of the search that keeps many scientists in the laboratory.